In this video, we'll look at chemical reaction lab and look at experiments 3 and 4, which are really two different twists for the same experimental reaction. I'm going to go to a screen share here. And in both reactions, what we're going to do is take hydrogen peroxide and break it down into water and oxygen. And the thinking is it would probably break down into hydrogen and oxygen because that's what hydrogen peroxide is composed of. But if we did a burning splint test, it would not pop. However, if we did a glowing splint test, a glowing splint would relight on fire, showing that we do have oxygen present here. So let's just make sure this equation is balanced. Hydrogen peroxide is H2O2, and water is H2O, and oxygen is diatomic, so it travels in pairs. I don't think I'm balanced here. I need to put when I got two oxygens here. Oh, and I got one here. So I got three oxygens and I only have two oxygens here. So I'm going to double this. That's going to give me four oxygens here. If I double this, that will give me four oxygens here. And notice 2 times 2 would be 4 hydrogens. 2 times 2 would be 4 hydrogens. So notice that hydrogen peroxide breaks down into 2 hydrogen peroxides, break down into 2 H2O, and then O2 gas. Okay, we're going to learn about catalysts and exothermic and endothermic and a couple other things as we do these reactions. But I think I'm going to switch away from this and get full view, switch away from the screen share. And let's get a better view of this. Move this back down here. So for reaction 3, I have the genie in a bottle one. I need to get a little closer like this. And I have a bottle which has 20 milliliters or about 15 milliliters of 30% hydrogen peroxide. The stuff you get in the store is only 3%, so 10 times stronger. But then I did dilute it with about 15 milliliters of water. So in essence, it's about 15% hydrogen peroxide. And you can see this. I have something dangling here, and it is potassium iodide solid wrapped up. Now, ideally, if I were doing this, I wouldn't let you see that. I'd put it in an invisible string or a piece of thread. I might paint this gold so that you can see when I might move this up a little bit. When I take the lid off of this genie, so I call out the genie, I unscrew it, I take the lid off. Now what that causes is the catalyst to meet the hydrogen peroxide, and then out comes the genie. This is getting really, really hot. And the bottle is actually shrinking, getting much smaller. Ouch. Okay. So it's really hot and that bottle is shrinking. It's much smaller. You can see like the ring around the coat thing is becoming less. So that's one reaction. And the other hydrogen peroxide reaction I have here is sometimes called old foamy or elephant toothpaste. I have a 20 milliliters of 30% hydrogen peroxide, and then I put some dish soap above it. And is it reacting? Maybe, but ever so slowly. Let's see if we can speed it up. And what I'm going to do is speed this up by adding, this time, instead of a potassium iodide, I'm going to add sodium iodide in a liquid form. And let's watch what happens. What was in there? Ooh, look at the steam being generated. So that's really heating up really, really well. So there's a couple questions in 3 and 4 that we're talking about. One is, what is a catalyst? The catalyst is, I guess for now, we're going to say it's something that speeds up a reaction without getting used up in the reaction. And that kind of gets to the second question. It says, is a catalyst considered a reactant or product? Not really either, because it's not used up in the reaction. It's not really either. And how is the addition of a catalyst indicated when writing a chemical reaction? I guess we'll have to show that when we go back to our screen share. So let's do that. I have to go to a different location here. All right, I think we can do that right here. And let's go back to screen share. And if I look at this, I'm going to go back here, and sometimes I'm going to write the catalyst right above the arrow. So it means it's not really a reactant, not really a product. It's just a catalyst triggering this thing to take place. And I think the catalyst we said was Ki, potassium iodide, and it's really the iodide that's the active ingredient that's making it go. All right, so that would be an example of how you would actually record that. Let's just scroll down and look at a couple of the other questions for number 4. And you can see their procedure there. And again, this would be balanced with a 2 to 2 to 1. We would have an NaI catalyst, but it's I as the active ingredient. Okay, is this reaction endo or exothermic? Both of these hydrogen peroxide reactions were exothermic. They gave off heat. Okay, so if the reaction gives off heat to the surroundings will feel warmer. In other words, I put my hand on the bottle or I put my hand by those bubbles and it felt warmer. Okay, the reaction gave off energy to me and I felt it getting warmer. So the reaction gave off the energy because it's exothermic, but it gave it off to me, so it felt warmer to me. Endothermic would be the opposite. It would be something that would happen where it would feel colder because the reaction took energy from me, and then it would feel colder to me. But both of these hydrogen peroxide reactions breaking down were exothermic. All right, that's for experiment 3 and 4. Thank you for watching.